So today is our second lesson for the graphing unit, and we're going to look at linear equations. We are just going to look at them at slope-intercept form. We're going to do some other forms in the future, but we'll start off slow. So first, you probably want to know what a linear equation is. Well, it looks like many other equations. It's made up of two expressions that are equal to each other. So some examples would be y equals 2x plus 3, y equals, oh, let's do some other ones. 3x plus 5y equals 6. Maybe 5x plus 6y minus 7 equals 0. Okay, so these are all examples of linear equations. They're two expressions, 1, 2, and there's an equal sign in between them. Again, two expressions and an equal symbol in between them. All right. A linear equation is a special equation because it has either one variable or two variables. So examples of what I'm talking about is that you could have something like this, x equals 5. You could have y equals 6. You could have y equals 2x plus 3. Notice now we have two variables. We have x and y. And no variable in a linear equation is raised to a power greater than 1. So a non-example would be y equals x squared plus 1. Notice that there are two variables, but the x is raised to a power of 2. So we can never have a linear equation with one of the variables raised to a power of 2, 3, 4, 5, and so on. It can only be raised to a power of 1. So an example is y equals 3x plus 5. Notice that we again have two variables, and neither of them are raised to a power greater than 1. And the other type that we can't have is we can't have a variable found in the denominator or the bottom of the fraction. So it cannot be found, no variable can be found in the denominator or bottom of a fraction. So some non-examples. Okay, so we cannot have this. This is not linear. Is 1 over x equals 5. X plus 5 equals 1 over y. 1 over x plus 3 equals 1 over y. So none of these are linear. Again, for linear equations, we'll have something like y plus 3 equals 2x. Maybe you'll have y equals 3x, again, plus 5. That's another example. And linear equations are used to form a unique line. And the line has an infinite number of points that actually make this up. So a line is just an infinite number of points. They get so close together that they actually form a line. Essentially, every linear equation makes up a unique line that could look like this, could look like this, could be exactly up and down, or exactly horizontal. And for linear equations, we also have an arrowhead. And all it's telling you is that even though we can only draw a certain section of it, the line continues going because I can always choose another value of x to get an output for y. You probably aren't sure what I'm saying there, so let's do an equation, or an example. So let's graph the linear equation y equals 2x plus 5. This is slope-intercept form. We'll talk about the form a little bit more next class. And all it means is that your equation is 1y equals something. All right, so we want to graph this. So our first step is to create a t-table. Now, traditional t-tables are just a t, and they have our x variable on top on the left side and our y value on the right hand side. Again, it's just like an ordered pair. It goes in alphabetical order. I'm going to add a little extra column here, and that's just going to be the ordered pair so we can see it all together, just like how we plotted the points last time or last class. Okay, so step 2 says choose a value for x. Now, when we're in this form, the easiest one to choose is x equals 0. So let's do that. Now, what does this mean? Well, I'm going to use a little bit more room here, and maybe just on the side, let's write down the equation y equals 2x plus 5. And my first value that I'm going to put in there is x equals 0. So wherever I see the x in my equation, I'm substituting the x as 0. So now I have y equals 2 multiplied by 0 plus 5. Again, we're following BEDMAS here. So the first thing we're going to do is multiplication, and then we'll do the addition after. So 2 multiplied by 0 is 0 plus 5, and then 0 plus 5 is 5. So when x equals 0, y equals 5. And we're going to put that in there. And our ordered pair is when x equals 0, y equals 5. Now step 3 says plot the ordered pair that you formed and label it. So let's plot it. We always start at the origin, just like last class. Horizontally, it's told us to move 0. So I'm not going to move to the right or the left at all. I just stay at the origin. Vertically, though, it tells me to move up 5. So I'm going 1, 2, 3, 4, 5. I put in my point. I'm going to erase this. And I'm going to write the point 0, 5 in. Alright. 4 says complete step 2 and 3 2 more times to choose different values for x. Alright, so let's choose, I don't know, let's go with x equals 2. You could choose x equals 3 or 4 or 5. It just depends on if it's going to fit in your graph. So if I choose x equals 2, again, I'm going to write it out over here. So I've got x equals 2. And now wherever I see the 2 in my equation, y equals 2x plus 5, so whenever I see the x in the equation, I'm going to substitute x equals 2. So I have y equals 2, x is now 2, plus 5. Y equals, and again, we're following BEDMAS rules, so I have to do multiplication first. And then I get y equals 4 plus 5 is 9. So when x equals 2, y equals 9. My ordered pair is when x equals 2, y equals 9. And now I'm going to go back to my origin and I'm going to plot this. So I'm always starting at my origin. I'm going 2 to the right, and then I'm going 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to erase this, and I get 2, 9. Alright, now we need one more point, and the reason why we need 3 is because if we make a mistake, then our line is all wobbly. So let's choose one more, let's choose a negative. That kind of will help us, because if I choose another positive, I'm going to end up off my graph. So try and choose one, a 0, a negative x, and a positive x. So we haven't done a negative yet. So I don't know, it doesn't matter. Let's just choose negative 3. I think that will fit still. Just for some extra room, I'm going to come here. And my x value is x equals negative 3. Okay, so y equals 2 multiplied by negative 3 plus 5. Y equals negative 6 plus 5. Y equals negative 1. So when x equals negative 3, y equals negative 1. And now I'm going to graph that. So I start at my origin. I'm going 1, 2, 3. Left because it's a negative. I'm going down 1 because it's negative. And I'm going to I'm going to label it. Oops, I forgot my negative there. Alright, so we've plotted that, and now it says draw the line that connects all of the points. Notice that all my points are in a straight line. If you get to this step and they're not in a straight line, then you haven't done it correctly. Okay? Every linear equation is going to create a straight line. If you don't have a ruler, it's okay. I don't have a ruler. I'm trying to do it the best fit I can. Try and make it look as straight as you can. Now, to finish this off, okay, so we've labeled it. That's great. The other things that we have to put on is our arrowheads, because I can choose an infinite number of other x's. And finally, I need to write the equation on here, and it has to be on the grid. And that was my last piece that I have to do. All right, let's do another one. We're following the same steps. So you have the steps in front of you. Step 1 was to create a t-table. Now I'm going to extend my t-table a little bit so I can put my coordinate on here too. It just helps you a little bit. Alright, we're going to choose a point. Again, in this form, the easiest one is to choose x equals 0. So let's do that. Now I'm going to write my equation over here again, y equals 1/3 x minus 2. I'm going to go a little faster now. Okay, so we've got y equals 1/3, x is 0, minus 2, y equals 1/3 times 0 is 0, y equals negative 2. So when x equals 0, y equals negative 2, my point is 0, comma, negative 2. I'm going to graph it. So my x is 0, I'm going down 2. 1, 2, I put in my point, and I label it. Alright, now for our next one we have to choose 3 values of x. It's not as simple as the last one because I have this fraction in here. And I don't want to have a fraction. Notice that on my grid I've got all these nice little corners, right? I don't have nice little decimal numbers. We have to really estimate a lot. So I want to choose a number for x that will get rid of my denominator. Okay, so choose a smart point. So when you multiply by x, you get a whole number. Or I guess I should say integer, because it could be negative. So for example, 1/3 multiplied by 3 would be a good example. 1/3 multiplied by 6. 1/3 multiplied by 6 is 2. 1/3 multiplied by 9. 1/3 multiplied by 9 is 3. Any of these numbers are going to make it so that 1/3 multiplied by x is an integer. So there's no fractions, there's no decimals. So let's look at that. So if I choose x equals, let's go with 3. Okay, so if x equals 3, y equals 1/3 multiplied by 3 minus 2. Now I did it like this so that I could put, remember, every number can be written over 1. So I can cross multiply here. I can cross simplify. Okay, so the 3 divided by 3 is 1. 3 divided by 3 is 1 as well. And therefore I get y equals 1 times 1 is 1. I have 1 on the top. 1 times 1 is 1 on the bottom. Now really, 1 divided by 1 is just 1. So I can erase this and put a 1 here. And then I get, actually maybe I'll just do this. 1 minus 2, which is equal to negative 1. So when x equals 3, y equals negative 1. My point is 3, comma, negative 1. So I go up here and I go 1, 2, 3, and then I'm going down 1. I'm going to put that in there. I'm going to label it, always labeling. And let's choose a negative 1 now. So instead of doing negative 3, let's do negative 6. Okay, so y equals 1/3 x minus 2, and I'm going to let x equal negative 6. Remember, 6 can always be written over 1. I can cross simplify here. 3 divided by 3 is 1. 6 divided by 3 is 2. So I end up with, on the top I have negative 2, on the bottom I have 1. Now really, negative 2 divided by 1 is just negative 2, minus 2. And I get negative 2 minus 2. They're going in the same direction, so we get negative 4. So when x is negative 6, I get y is negative 4. So I'm going to count it from the origin. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Put in my point. Erase that. Negative 6, comma, negative 4. I've got my 3 points in. Notice that they are in a straight line. And I'm going to draw my line through here. I've got to get my arrowheads on there. Okay, so notice I've got, oh, I forgot a little bracket there. Everything's labeled. My points are all labeled. My arrowhead's on there. The last thing I need to do is write the equation on here. Y equals 1/3 x minus 2. And I've got everything on here. So just as a little aside here, if I chose a value for x that is not, I'm going to just do nice. So when I multiply by 1/3, I don't get an integer. So for example, if x equals 2, then I'm going to get y equals 1/3 multiplied by 2 minus 2. Then I get y equals 2/3 minus 2. Well, then I've got to do y equals 2/3 minus, now remember 2 is always over 1. We need common denominators to minus fractions. So that means I'm going to multiply the top and the bottom of this one by 3. And then I get -4/3. This isn't very nice to graph. I mean, you can put it into a mixed number too. -1 and 1/3. It's the same thing as -1.3 repeating. It's not nice to graph. So try your best to find at least 2 to the 3 points that are integers. So there's no decimals. So integer, no decimals, no fractions. Just a nice positive or negative number. All right, that's graphing linear equations day 1.